Okay, so for test one, here is the sections that we covered. 1-1, we started there. That was kind of more for review purposes. I don't know that I'll specifically ask a question on section 1.1, but then we went into the chapter 1 a little bit. Covered 1.4, 1.5, 1.6, 1.8, 2.1, which, you know, the review sheet has questions like will be on the test, and so be sure to take a look at that review sheet and turn it in if you do the review sheet for points. But anyway, just thinking about those sections, 1.4, well, that was that's where we started. That was the slope of the tangent line by using the table of secant line slopes. So yeah, there will probably be a question on that where you have to do, take a function, come up with the, whatever the function is, the slope. To find the slope of the, in 1.4, the way we did it was, we came up with this slope of the secant line, we call it NPQ. But the slope of the secant line is we've got this function, and y equals f of x, let's just call it. And whatever the a is, we want the slope at a f of a. Well, that's the point P we wanted at, and then the Q is, we just come out a little bit from that, call it x, and then f of x. And it looks a lot like what we came up with in 2.1 anyway for the definition 1. We'll talk about that in just a second. But yeah, this slope formula, it's just the difference of your y's over difference of your x's, and so that's, I usually have you write out, I'll have a particular function, but whatever the f of x is minus the f evaluated at a, and then x minus a. So that's what 1.4 was, is then you do a table where you do your xq values and then calculate these mpq values and see what, get the xq closer and closer to the a value. So there'll probably be one like that, and it's on the review sheet here. I think it's number 9. This is like number 9 on the review sheet there. Let's see, 1.5. That's where we start talking about limits, and so yes, be able to do limits from a graph. We talked on 1.5. We talked about factoring, using factoring, and the conjugate, and all that good stuff. But also in 1.5 was finding the limits from a graph. If it's saying find the limit from the left or from the right, be able to find those limits like that from the graph. So don't forget about that. And of course also the infinite limits. We had those methods, like I said, for finding limits, factoring method, the conjugate, using the conjugate. And really just one of the techniques was simplifying, like if you've got like a x plus 2 squared, we'll square that out if we need to simplify. If we can't plug in the value, simplify that out, multiply it out, or and that sort of thing. And then combining fractions. Yeah, if you're a numerator or denominator, for that matter too. But you've got a complex fraction, meaning a fraction on top, as well as a fraction on top of a fraction. But yeah, you might need to combine fractions into one fraction. So those are techniques we talked about. I will have you do, though, also limits by using a table. You know, these are a preferred method. If we can do them by these methods, that's what we prefer. But using a table is important too. So be sure to know, you want your x values closer and closer to whatever value you're going to. So that will also be part of the stuff from 1.5 there. Let's see. 1.6. Oh, actually, 1.5 is the table stuff, and then 1.6 is the methods, different methods using those. And it says using limit laws and methods. I'm not going to make you memorize those limit laws. You don't have to use those limit laws. I just had you do a couple on the homework, and so that'll be sufficient for those. So you don't have to know those limit laws. Just be able. What the limit laws basically allow us to do is to substitute in. If we get it down to eventually, like if I have the limit as x approaches 2, let's say, x squared minus 4 over x minus 2. These methods allow me to get to where I can substitute in. I would use the factoring method here. These are the top factors. And then the x minus 2's cancel. But the limit laws then, they're what allow me then, once I reach, because I can't plug it in here because the denominator is 0. But once I reach the point now, since I just have x plus 2 here, the limit laws allow me to substitute those in. So you don't have to know which limit law that is that allows you to do that, but that's what the limit laws allow us to do. Yeah, so those 1.5 was the table, and then limits from a graph, and then 1.6 was these methods. 1.8 was that's the continuity. So be sure to know what it takes for a function to be continuous at a value, and thus what it means to be discontinuous. Continuity, there's three things. You got the limit as x approaches a of f of x that exists. You've got the function at a is defined. And then the last one is those two are equal, right? So there's basically three parts. Three parts to, if all those three are satisfied, then it's continuous at A, we would say. So that's 1.8. And then also 1.8 continuous from the right or left. Be sure to know about those. And then 2.1, what we finished up here on. 2.1, that has two definitions, if you will, or two expressions for the slope of the tangent line. It turns out this is a limit process, and so definition 1 says the slope of the tangent line is the limit as x approaches a of f of x minus f of a over x minus a. And then another form that allows us to find that slope of the tangent line, equation 2, is m equals the limit as h approaches 0 of f of a plus h minus f of a over h. Okay, so I will have you work problems, probably one on each of those. And I don't make you necessarily memorize those. Those will be on the test. So just so FYI there. But yeah, be sure you can work with those. That just that gives us a way to do these slopes of the tangent lines by using a limit, which is essentially what you're doing with this table here from 1.4. We just didn't call it a limit at that time, but that essentially was what we were doing. Maybe we did call it that, but this gives us a more direct way, I call it, calculating those. So anyway, that, whoops, yeah, that's our test for test number 1.